All right, guys. Today we're going to solve the LeetCode problem for reversing an integer. It's the number 7 problem. This is a medium difficulty problem. We are going to be doing it in the best time that we can in big O notation. By that, I mean we're going to be doing it as O log n. It's going to be the most efficient way to do it. And we're going to do it with a space complexity of O of 1, basically meaning we're not really going to add any more space or really utilize any more space than we have to, right? Having said that, let's jump right in and talk about the thought process behind the problem before we actually look at how to do the problem. So my head is kind of in the way, but I'm going to read sort of what it says here, and then we're going to talk about the logic behind it, and then go through the code and explain what the code is doing to help you remember it. That way you understand what you're doing instead of memorizing it. Understanding will help you retain it longer than just memorizing sort of a formula. So what it says here is, given a signed 32-bit integer of x, return x with all of its digits reversed. If reversing x causes the value to go outside of the signed 32-bit integer range, and then it explains what the range is, then it wants you to return 0. All right, and then what this is saying is just assume the environment doesn't allow you to go to 64-bit. Basically, you just can't go higher than the 32-bit, all right? So what we're going to do here is we are going to think about this problem logically real quick, okay? So if we have the number 123, we need to get it to be 321, but we need to iterate through this process. So we need to take the number 3 and start with that. And then we need to add the number 2 and then add the number 1. So when you think about reversing it, don't think about reversing it like an array where you can just use pointers and switch them around. It's not going to work that way. Think about it as a multi-step problem. You're going to start with this. The next step is going to be getting the number 3 by itself. Then we need to add the number 2 behind it, and then we need to add the number 1 behind it. How do we accomplish that? So this is the code in order to achieve this process. I'm going to walk you through the code, and then I'm going to show you what it does each iteration to help you understand it logically. The first thing we're going to do is initialize the results. These are going to be the results of the loop that we're getting ready to do. This is going to be what we're going to return. It's going to be the reverse of the integer x that we're given and passed in. To start this process, we need a loop. And what we're going to say is this loop is going to repeat as long as the number doesn't equal 0. So seeing this, your mind might go, this is going to iterate a lot. But this is still the fastest way to do it. And it doesn't iterate as much as your mind would think. Just follow the process and you'll understand. So the first thing we're going to check is the result either bigger than the maximum allowed value of an integer, or is the result less than the minimum amount? And we're going to divide that by 10 because that is how we are passing it through the equation. So essentially what this is doing is making sure that we are not going out of scope, which would cause a problem. And that's what it asks us here to do. If the value goes outside of the range, to return the 0. This accomplishes that. So the first thing we have to do is establish our digit. And the digit is going to be the thing that we add to our results every iteration. In order to get this, we're going to take the x that we're passed in and we're going to modulus it by 10. The next thing we're going to do is we're going to take the integer that we were given and we're going to divide it by 10 and then set x to be that result. After that, we're going to take our results that we had initialized to 0 and we're going to set those to be equal the results times 10 plus the digit that we got from the modulus expression above. After we do that, we're going to repeat the loop. We're going to do that until x equals 0. When it's done, we're going to return the results. As you can see, I've already ran this, and it does indeed meet all of the test cases, and it has a very fast runtime. So that's all good and well, but what does it mean and what does it actually look like? This is going to be the part that really helps you understand the function and helps to really cement it into your mind. So what we're going to look at here is we're going to do our own starting number. So for us, we're going to iterate through the starting number of 4,659. So this is essentially what the program is doing, and we're going to walk through it step by step. So in the first pass of the number through the function, what we're going to do is we're going to take 4,659 and we're going to take the modulus 10 of that. Basically what that's doing is giving us a remainder of 9. So we're going to set digit to equal 9. Afterwards, the next step, right, was taking 4,659 and dividing it by 10. Essentially what you would get is 465.9. However, integers do not store decimals and they don't round. So what happens is the 9 drops off and you're left with a new x of 465. Now, the next step down in the loop was to take results, which were initialized as 0, and to multiply that by 10, and then add the digit that we got from the modulus operation. So after you do that, you get a value of 9. So this is your results. Your results are 9. Now, we went through the loop. We're going to go back through the loop again. So our x, remember, was set at 465. So 465 modulus 10 gives us a remainder of 5. We set 5 to the digit. The next thing we do is we take that same 465 and we divide it by 10. When we do that, we get 46.5. Again, the int doesn't store the decimal, so we drop it, and our new x is 46. Now, the final step of that loop was to take our results, which were set at 9, times 10, and then add the new digit. Essentially, what you're doing is you're moving the 9 over to the left and appending the number to the end of it. That's the easiest way to think about it if you don't want to think about it in mathematical terms. You're just moving the number to the left and slapping the 5 on the end. Okay, so we're going to iterate back through again. And what we're going to do is we are going to take the 46 from here, our new x, and we're going to modulus 10 that again. That's going to give us a remainder of 6. So that's our new digit. We're going to take 46 and divide it by 10. That's going to give us 4.6. We're going to drop the 6, and that's going to give us our new x of 4. Now we're going to take the 95 that we got from our previous results. We're going to multiply it by 10, which moves it all to the left one. And then we're going to add the 6 that we got from the modulus here to the end of it. We're going to add it or append it or concatenate it, however you want to say it. Essentially, we're just adding it and moving the numbers over. You're starting to see the pattern. So we're at 956 here for our results. Now, this is going to be the fourth and final pass. For the fourth and final pass, we have 4 modulus 10. That's going to give us a remainder of 4. We're going to take 4 and divide it by 10. That's going to give us a value of 0.4. The int doesn't store it. We drop it off. That sets our x at 0, which we know will end our loop after this. The next thing we do is we take our results, 956, multiply it by 10. Essentially, we shifted over 1 decimal point. And then we're going to add the 4 that we got from the modulus operation here. So, for those of you playing the home game, our starting number was 4,659. Our new number is 9,564. As you can see, the numbers all changed places. All right, now that we've worked through the iterations, let's re-examine the code one more time and just talk through it so you can see exactly what's happening, and it should make a lot more sense. We're going to initialize our results at 0. While x does not equal 0, we're going to do a loop. We're going to verify that results are not outside of the integer bounds after being divided by 10. If they are, we're going to return 0 because that's required. If it's not, we're going to go into the loop. We're going to set our digit to be x modulus 10. We're going to take x, divide it by 10, and reset x. And then we're going to take our results, and we're going to multiply them by 10, moving them 1 decimal point, and then we're going to add the digit that we got from the modulus onto the end. We're then going to repeat this as many times as necessary until we get down to a 0 in the x divided by 10 operation. After that, we're going to return our results. Hopefully this helped you. I know for me, it took a minute to really get my brain thinking like a programmer, but this is the most optimal result and the way you should be doing it. Thanks for hanging out. Hopefully you enjoyed the tutorial, and I will see you in the next video.